In this video, we'll go over some tips for searching in Web of Science. Specifically, we'll go over Boolean operators, truncation, phrase searching, parentheses, and query sets. We're going to start on the basic search, where we'll do some searching using Boolean operators. Let's say that I'm doing research on conservation of the Great Barrier Reef. If I were to search for the words Great Barrier Reef, this is going to search for any of those words showing up in any of the records, not necessarily together. First, I'm going to search Great Barrier Reef without quotations to see how many results I get. You'll see that when I don't use quotations, I receive 9,630 results. The records that show up at the top of the search also don't have very many things that are highlighted in yellow. This is because I'm currently sorting by date, which is the default in Web of Science. I'm going to change this to relevance, and I should get the more relevant results at the top of the search. Now you'll see that I'm getting searches that have more words highlighted in yellow. Some of them do have the words Great Barrier Reef right next to each other, which is great. But I want to see if I can get fewer results by adding quotations around those words. To go back to the search, I click Search under Web of Science, and I'm just going to add quotations around this phrase, and search again. You'll see that we end up with about the same results, but now all of the results that we see on the first page include the words Great Barrier Reef right next to each other, so that's a good start. Let's say I also want to look at conservation of the Great Barrier Reef. I'm going to go back to the search and add conservation with a Boolean operator. To do this, I can add another field, and our Boolean operators show up on the left. You'll see that I have the Boolean operators and, or, and not listed here. If I were to use and conservation, this would be searching the database for Great Barrier Reef and conservation, meaning that it would return results that include both Great Barrier Reef and conservation. It has to include both. If I used or, it would search for records that include either Great Barrier Reef or conservation. I would get articles that include both, but I might also receive articles that are only about the Great Barrier Reef or only about conservation. Not is a little bit different because it lets you limit your search down further. It says, I want this first thing, but I don't want the second thing. If I were to search Great Barrier Reef, not conservation, it's going to get rid of any articles that talk about conservation and only focus on the Great Barrier Reef, but other aspects of it. I'm going to do some of those searches now to show you how that works. First, I'll start with Great Barrier Reef and conservation. You'll see when I do this search, I get 876 results, and most of the results at the top, you can see the words Great Barrier Reef and conservation included in the title. I'm going to go back and change this to or. So this is going to search for Great Barrier Reef or conservation. The results it returns will include either Great Barrier Reef or conservation or both. Let's see how many results we get. So we received 334,000 results for this search, which is way too many things to look at. Let's go back and change our search by applying the Boolean operator not. This would be useful if you were looking for articles on the Great Barrier Reef, but you didn't want to write about conservation, so you wanted to get rid of the articles that were about conservation specifically. When I search this, that cuts down the results to 8,500 or so. You'll see that they include the word Great Barrier Reef on a lot of the top results, but conservation is not listed because we said we do not want conservation to be included. I'm going to go back and show you some other tips you can use for searching as well. Let's say I am writing a paper on the Great Barrier Reef and conservation. I'm going to change this Boolean operator to and. But let's say when I search, I'm not getting enough results. So maybe conservation isn't the word that someone used. Maybe they used the root of the word, but it has a different ending. What I can do is use a truncation symbol, which will change our search and open it up to more words with the same root word. So if I add an asterisk after conserve, it's going to search also for the words conserve, conserving, conservation, conservative, and conservatorship, as well as any other words that have the same beginning. You can also put the asterisk at the beginning of a word, and it will search for different beginnings instead of different endings. I'm going to search this and see how much our search changes. So now I got 1,004 results, which is a little bit more than I was looking at before. That just means that people who have published these have used words other than conservation, but that are related. I'm going to go back to my search. So far we've been searching in the basic search, but we can do a lot more if we use the advanced search in Web of Science. I'm going to go to the advanced search now. And this page looks a little bit different. So for this, you will be creating query sets, which use the field tags located over on the right side of the page and sets of parentheses to do searching. The way this works is they're basically like mathematical equations. The queries start with what's in the parentheses and run that part first, and then anything outside of it is run afterward. I'm going to show you some examples now using our topics of Great Barrier Reef and conservation. So for example, in the advanced search, if I just wanted to search search for Great Barrier Reef and conservation, here's how I could do so. I would start with TS, which stands for topic, equals, parentheses, and then I'll do Great Barrier Reef in quotations, since I want that to be a phrase, Boolean operator and I'm going to do conserve, asterisk, and close parentheses. If you leave one part out for the equation, this will give you a warning and let you know what's missing. I'm going to do the search now and see what comes up. You'll be able to see my search history at the bottom here. The search that I just did is at the top, which shows 1004 results, which is basically the same thing that I was searching for before in the basic search. I'm going to go back and change this a little bit and see what else I can come up with. Now I can do this either by scrolling up and typing in a new search, or if I just want to make changes to a search that I've already done, like this top one, I can go to Edit. You have two options when you do this. You can actually overwrite that existing search, or you can create a new search. They call different searches sets. So I'm going to create a new set for this, and I'm going to try out using a different Boolean operator. So in Web of Science, there's also the Boolean operators same and near, which are listed on the side of the page here. These are a little bit different because they behave in different ways. So near will actually search for the words that you're using within a certain amount of space of each other in the article. So if I were to put Great Barrier Reef near conserve, by default, it's going to make sure that those sets of words are within 15 words of each other in the article. If I do /10, it's going to make sure that they're within 10 words of each other. I'm going to do this search now and see how many results we get. You'll see at the top of the search history, this will bring back 34 results. To see those, I just need to click on the number 34, and here's my list. You'll see that these words are either this close together in the title, or if you go look at the abstract or the full text, you'll be able to see that the words are within that distance of each other there. So that's how near works. It just says, I want this word or this set of words this close to the second set or word. I'm going to go back to search now. Something else to keep in mind is when you're using the queries, the parentheses is what is run first. So I'm going to show you an example of that. Let's say I couldn't make my mind up about whether I wanted to write about the conservation of the Great Barrier Reef or if I wanted to write about the Amazon rainforest. To do a search where I can view conservation for either of these, I could format the query in this way. So I will do TS, which is topic, equals, parentheses, Great Barrier Reef, in quotations, or, in quotations, Amazon rainforest, close parentheses. So this query starts off saying, I either want articles about the Great Barrier Reef or about the Amazon rainforest. If it includes both, that's fine, but please show me things that have either this or this. After that, I can add, and I want the topic of conservation. And I'm actually going to use the asterisk here to get any of the other endings of that word. So now it's saying I want Great Barrier Reef or Amazon rainforest, and I also need conservation to be included in that as well. I'm going to do this search and see what comes up. You'll see here that I got 1,089 results, which is more than I got for just searching Great Barrier Reef and conserve. I'm going to click on my results here and see what I have. So you'll see these first few results are definitely about the Great Barrier Reef. I'm going to keep scrolling down, and this result at the bottom is about conservation of the Amazon rainforest. It doesn't have a mention of the Great Barrier Reef in it, so this article is probably not about that. So in this way, I can kind of expand my results a little bit. I can look at things that are about one topic or another and give the qualifier that it needs to be about conservation as well. So far we've talked about Boolean operators that you can use, how to use quotations for phrase searching, using parentheses and queries, and we talked a little bit about truncation. There are actually some other types of truncation that you can use as well. I'm going to go back and do a different type of search. For this one, I'm actually just going to do a basic search because I'm going to show you how these work. I'm going to reset this form because I'm going to use different words. So there are two other types of truncation. The first is using a $sign. The $sign says, in this word, there may be no character in this spot, or there may be one character added. The way this works is for instance, for the word color. Color in American English is spelled C-O-L-O-R. In British English, it is spelled C-O-L-O-U-R. To search for both ways that color is spelled, I would type $COLO$R, and that's going to tell the database I'm looking for either the word color without a U, so nothing in the spot where the $sign is, or there could be a U listed here, or another letter. I'm going to do this search and see how many things come up. There are 489,000. When I do this search, you'll see that it's got the word color with a U up at the top. But if I go down into my search, here's the word coloring without a U included. So that's one example of another way to use truncation. There's also a question mark that you can use for a different type of truncation. It basically says, this one character may change. This is useful for words like gray, which can be spelled differently depending on your location. If you type GR?Y, it's going to search for either of those spellings. When I do this search, you can now see that it's got gray matter spelled with an A, gray water spelled with an E. So if you were searching for gray water as a topic, you may want to include that question mark in place of the E or the A to make sure that you're getting all of the results that you're looking for. The last Boolean operator I want to go over briefly is a little bit different. Same is used for address searching. Address is signified by the field tag AD. Basically what same does is the same thing as an AND search does with a Boolean operator. It looks for two or more things to appear in the address field of the records you're searching for. So for example, I could search AD equals parentheses. Let's say I want to search for the city of Knoxville, but it also needs to include Tennessee in the address. I'll type Knoxville, same, Tennessee, and do this search. You'll see when I do the search, there's 76,000 results. And when I go to this, you'll be able to see the results here. Now, you won't be able to see anything directly on the results list related to the search that I just did. You can go down to the bottom and select organizations if you want to limit by that. But if I go to one of these by clicking on the title for the record, you'll see that under addresses, it's got the information that I was looking for highlighted. I could also search for Univ Tennessee, for University of Tennessee in the address field, and that would work the same way. Same is a little bit different because sometimes there can be more than one address listed on an article. This will happen a lot when people are publishing together and aren't working at the same university or same organization. That's basically how same works. Definitely give these Boolean operators and other tools a try when you're searching in Web of Science. Don't be afraid to just try out different query sets. I know it can look a little bit intimidating at first because it looks like you're building a math equation with words, but don't be afraid of trying things and seeing what works. You can't mess up the database by entering a query in the wrong way. If you enter something incorrectly, it will tell you what's wrong with it. If you run into any problems making queries or deciding how to search, stop by the library and we'll help you do that. In our next video, we'll talk about using limiters to further limit your search.